and completion of a particular activity. So we're going to use activity on node. There are some rules. When you're drawing a network, the flow is always from left to right. Now, this is important because sometimes when you're drawing a network, you might not know when it's going to stop. And I've seen sometimes people start on the left-hand side of the page, move across towards the right, run out of room, and then start to come back from right to left. Well, that's not the way to do it. What you do in that case is you carry on, you add another sheet of paper and carry on going from left to right. Okay, so it must always be left to right. The second rule, an activity can't begin until all the preceding connected activities have been completed. So if you've got an activity that's due to start at a particular point in time, and say it's got 3 different activities that feed into it, all those activities feeding in must be completed before that subsequent activity can take place. The arrows indicate precedence and flow, and they can cross. Usually when you produce a network and the arrows cross, you can, a little bit like when you're doing flow charts, you can put a little semicircle on the arrow just to show that they're crossing. Each activity should have a unique ID number, and that comes back to what I was saying just now and what we talked about last week. Activity ID numbers must be larger than any preceding numbers. So if simplistically we had activities 1, 2, 3, 4, 5, as we go from left to right across the network, 1, 2 and 3 have got to come before 4 and 5. So we couldn't have 1, 2 and 4 feeding into 3. We don't want to see that sort of thing. We want to have a nice flow with increasing numbers. No looping, so you can't loop back on things. It has to be a flow through from one end to the other. And there are no conditional statements, so you can't say any what ifs in it, and that's not allowed at all. It's if this happens, and that's the end of it. And then we have what are called, we have a rule that says we need to have common start and end nodes. So you should start from one rectangular box on your network and you should complete in a rectangular box. These are the sorts of constructions that we would see. So very, very simple at the top. We've got A, B and C, with A occurring before B and B occurring before C. We've then got the one below it where X then is split and goes into Y and Z. We've then got the example that I gave just now where we have 3 activities feeding into one, and then we can have a much more complex situation where different activities feed into each other. If we were to represent that as activity on arrow, that's what it would look like. No need to worry about that. I'm not going to ask you to do anything along those lines. Just be aware of it as an alternative way of representing a network. So I'm going to go through an example here. This is an example taken from a textbook that I recommended to you at the beginning. What we have here, just go back again, sorry. What we have here is a very simple network, no numbers on it. Yes, the activities have ID letters on them, the A, B, C, D, E. There's a little bit of description as to what it is that particular activity is about, and that's helpful. And what we're going to do now is we're going to look at the time side of things with this particular network. So we do 2 things. We complete what's called the forward pass and then the backward pass, and they're based on the earliest times on the forward pass and the latest times coming back. So we have these different terms that we're going to use. ES is early start, EF early finish, and LS is latest start, and LF is latest finish. So if we look at that example again, you can see now what's happened is that box has no longer just got A and then a piece of text to describe it. What it's now got is it's been partitioned into a series of smaller boxes. Now the identifier always goes at the top in the middle, So we've got the A, B, C, D all the way through. Top in the middle, that's the ID. You can see the little bit of text is still there, slightly smaller box for it to go in, but it's still there. And then you can see directly below the ID on the bottom line, you've got the duration. Now this example, I'm not going to worry too much about it, but you need to actually specify this, as I said earlier. Is this hours, weeks, days, months, whatever? You need to make sure that you understand what that number represents. So then what we're going to do on the forward pass is we're going to go through and we're going to put all of the ES and the EF values in. The ES and the EF values, they go either side of the identifier on the top row of the box. And we have to start right at the very beginning with the number 0. So the way this works, if we take box A furthest to the left on the screen, that previously, if you remember, we only had the description and we had A and 5 in that box. Now what we've done is we've added a 0 into the first box, which is the early start box, the ES box. And then what we've done is we've said, well, it starts at 0, it has a duration of 5, so the earliest it can finish is going to be 5. So on that top row we have 0, A, the identifier, and then 5 as the earliest finish value for that particular activity. We then do exactly the same thing with every other activity in the network. The only thing we have to be aware of is that for some activities, they might have more than one arrow feeding into them. Okay, then we have to make a decision. So if we look at B, C and D, they're all fairly self-explanatory. The 5 transfers to be the early start value for each of those activities. We then add the duration to that to give us the early finish value for each of those activities. So hopefully B, C and D are all fairly straightforward. If we then look at E, we can see that E, which is on the very top towards the right of the screen, we can see that we've got an arrow coming in from activity B, and we've also got an arrow coming in from activity C. And both of those activities finish at different times. Excuse me, just having a drink of water. So we've got a 15 coming from C and a 20 coming from B. Now remember what I said beforehand, the activity can't start until all of the preceding activities have finished. So you'll notice that the early start value for activity E is 20. It can't be 15 because if it were 15, B wouldn't be finished. So it has to wait until B's finished and then the 20 pops into that box. We then go through the same motion with E, add the 15 to give us the 35. Now, it's a little more complicated with activity F, but the same logic applies. So we don't need to get, it's more complicated. There are 3 arrows rather than 2, but the same logic applies. We just pick the largest number. So it's 20 goes in there as well. And hopefully then you can see how we get all the way through to the end of the network, and the final value becomes 235, let's say, days for this example. So 235 days to finish this particular project. Now obviously this is a very simple example. When it comes to putting all this data together for a more complex project, that's where IT becomes really valuable, because it's going to crunch all these numbers and do it for us as a project manager. The point about it is it's important to go through a few small examples ourselves, because we need to know the logic. We need to be able to sense check anything that a computer produces to make sure that we're happy and we believe it's legitimate when it comes to sharing it with a client or using it as the basis for our project. So that's the forward pass. Any questions on that forward pass? Has everybody followed what I've just explained there? There's some typing going on, so I'll just hold a second. Yep, okay, that's brilliant. Now, that's the forward pass. We then need to do the backward pass. And the way the backward pass works is that what we do is, because the project was identified as taking 235 days, to get us started on the backward pass, because the backward pass is going to be filled in, it's the bottom row of each box, and we're going to fill it in moving from right to left. So we're going to start with activity H. What we're going to do to start us off is, just as we put the 0 in the furthest left box on activity A on the top row, we're going to let the 235 drop down into the furthest right box in activity H on the network. Okay. Then what we're going to do is we're going to go back and we're going to fill in all those boxes on the bottom row all the way through to activity A. But this time, rather than it being addition, we're going to be doing subtraction. So if we look at this particular activity, activity H, we have 235 minus the 35 gives us 200. And then the 200 is the number that feeds into the activity boxes for E and G. We then do the subtraction again, come up with a number out of E, a number out of G, and then we take it all through. Now, where we get now to a point where we have multiple activities feeding into an activity. So let's take the example of B, because it's up the top there. You can see B, we have activity E feeds back into B, and activity F feeds into B. Now, from activity F, the number that we're carrying forward is 20. And from activity E, the number we're feeding forward is 185. So, which one do we take? Well, on the backward pass, we always take the smallest number. Remember, on the forward pass, we took the largest number. On the backward pass, we take the smallest number. So it's the number 20 that goes into the furthest right box of the bottom row of activity B. Similarly, when we're thinking about activity C, it's again 185 and 20. So therefore we can finish everything for B, C and D. And then we're faced with 3 arrows coming into activity A on the left side of the network. And here we have a 5 coming down from B, we have 10 from C, and we have 15 coming from D. And again, same logic, we take the smallest number. So it's 5, we then take the 5 and we get a 0. That's really important. With that first activity, we really shouldn't be seeing any what we call slack at all. And so what we're looking for there is we're looking for a 0 in that furthest left box, both on the top row and the bottom row. Okay, so that's the backward pass, and then we would do that and put that all together. Now, the one thing, or a couple of things here that we need to just point out. There are some empty boxes. If we go back to the previous slide, if you remember, if we've got the top row filled in, we've got the bottom row filled in, there's this one box that wasn't filled in that's got SL on it, slack that is, which is the middle row furthest to the left of each activity. Now what we've done is we've put those slack values in on this particular completed network here. Now the slack value is very simply the difference between the two numbers, the early start and the latest start. And so if we take an activity such as, let's take D down the bottom of the screen, okay, activity D, we've got early start of 5, latest start of 15. It means that potentially that activity could start any time between 5 and 15. It can start at 5 and it has to be started by the time it gets to 15, but depending on how the project's running, there's a little bit of flexibility in there. In fact, 10 days worth of flexibility in this case. So that particular project could start at any time between 5 and 15. You'll also notice that on this particular diagram, certain of the boxes have got a dotted line around them. And that's because they represent the critical path for the project. If you take any other route other than that identified by the boxes and the dotted arrows, the dotted boxes and the dotted arrows, you'll see that there is a number in the slack box other than 0. And that means there's flexibility in the activity, so it can't be on the critical path, because the critical path is the path where all of the activities have 0 slack. Now, from the point of view of the project manager, the slack is really helpful because it gives us some flexibility to decide how we schedule our work. Okay, so we really, you know, it's a benefit to us. We wouldn't want to see a project necessarily with critical paths all the way through, so every route through had 0 slack. We have to use it wisely though. It's not free. It's something that we need to consider. When we're thinking about the network more overarchingly, it's important to, here we just use A, B, C's, D's. If we think we might need to make some changes to our network at some point, it's often a good idea to have gaps between the identifiers. So if we have 1, 2, 3, 4 or 1.1, 1.2, it's good to leave gaps if we think there's potential for new activities to come in at some later stage. We need to avoid what we call dangler paths. What these are where we have just an activity that might, say there was an arrow, take F, say there was an arrow that went, as you can see here, to G, but then there was an arrow that went down to another activity below it. We'll call it J for the moment, say. So we then had effectively 2 potential finish points if that J wasn't then connected back into the network. That is called a dangler, and we don't want those. We want a common start and a common end. And then, from the project manager's perspective, the question we need to ask ourselves is, does it make sense? Overall, does it make sense? And that's what's really, really important. Particularly if you've got some software that's creating the network for you, you need to be clear that it's going to make sense. Often what we do then is, the other tool that we use along with the network is the Gantt chart. You can transfer the information directly from the network into the Gantt chart and produce something akin to that at the bottom of the screen, and that's often the way we communicate on projects. So something looking a little bit like this, where you can see the interconnections between the activities, they're spaced out over the timeline, and you can see how things are going to plan out from the perspective of the overall project. There are a few different things that we need to consider. It's not all that simple. There are 2 things that I'm going to share with you now, the idea of laddering and the idea of lags. So if we look at this one, what we've got here is we've got the idea, what we're doing here is we're basically digging a trench, putting a pipe in and filling it back up again. And so what we've got here is an activity on node network that shows laddering. So basically what we're doing is we dig a third of the trench, and then while we're digging the second third of the trench, we're laying the first third of the pipe. And then when we're digging the final third of the trench, we're laying the second third of the pipe and filling in the first third. So you can see how we can actually shorten the time of a project. We don't have to dig the trench, lay the pipe, fill the trench. We can actually split it up to enable us to complete it more efficiently. And then at the bottom, what we've got is the idea of a lag between two activities. Now what we do with this particular example is we write what the lag is, in this case let's say 2 days, on the line that goes between the two activities. And what it means is that if, for instance, we're doing the forward pass, okay, if for instance the latest start on the earliest finish on the activity X, say it were 10, and then it's feeding into Y, we've got a lag 2. What we have to do is we have to add the 2 days onto the 10. So that means the early start for Y is not going to be 10, it's going to be 12, because we're going to add 2 additional days in. Now what does that mean in reality? It might mean that it might be a delay to receive some materials. It might be that you've done something and you need to let it cure or dry before you can do the next activity. So that's what that lag 2 represents. It represents some sort of waiting time, holding time, because of some particular feature of the project. And those lags can occur in all sorts of different ways. What we saw there was a nice simple lag between activity X and activity Y. But you can have what we call a start-to-start lag, which is what we have, what we have at the top graphic, where we've got activity M and activity N. And we call it a start-to-start lag because it comes out of the start of activity M into the start of activity N. Okay? We've then got the exact opposite next door to it, where we've got prototype and testing with a lag 4. We've got a finish to finish. Okay, so what that's saying is the testing can't finish until at least 4 days after the prototype has been completed. So if you think about the logic behind it, it actually makes it much more intuitive and you can follow what's going on. We've then got a start to finish in the bottom one on the left hand side, so the testing system documentation one. We've got coming out of the start but going into the finish. So what it says is that the system documentation can't be completed until at least 3 days after the testing has started. And then what we've got, the final one, is with the code and the debug, is we've got a mixture of the two. So what we've got there is we've got a finish to finish and we've got a start to start. So most of the mathematics associated with producing a network is simple addition and subtraction, but when you add the lags in, it becomes just a little bit more tricky. So long as you understand what they mean, it will make sense. The whole idea of those, though, is to try and take, just as with the trench example just now, is to take something that would traditionally be quite sequential and to turn it into something where you've got some parallel working taking place, so what we call concurrent engineering. So what this enables us to do is hopefully get to the point where we can complete projects more efficiently, quicker, and meet the customer needs much, much better. So it's really, really important to do that. Okay. I'm done now, so that's all I wanted to go through with you with regards to slides. You got any questions that you want to ask before we move on to the work breakdown structure? No? Right, okay then, we'll move on. If you remember, what I asked you to do last time was to consider this particular scenario, a laboratory, and you were being asked to produce a work breakdown structure for creating that laboratory. I wasn't 100% sure who everybody was that was involved
Ну давай, я не знаю, ну, то есть можешь минут через 30?